Where are the issues? Did I just mute you, Waylena? Huh.
There we go. Okay. The portion where you find the actual menu items.
Portion where you find them.
Right, where you would find resources and events.
They're all up at the top I've last seen. Let me take a look at it right now and see what I can bring up. And because other people would want to see this,
exactly,
and we're delaying the start of the show. Hi, everybody. Thank you. I will go ahead
before we share them during the presentation.
Absolutely, absolutely. So let me go ahead and do this. I'm going to switch over to a certain type of camera view through OBS here. I think this is my correct one. Nope, that ain't the one. Okay, lecture slides. There's my guy. Okay. Hey, now everybody sees me in the corner with a Google window open. Perfect. All right, so.
You keep disappearing.
Oh, is my video feed disappearing constantly? Yeah. Oh yeah, look at that. It's because I still have the virtual background. I'm sorry. Yeah. I wanted to greet you folks and then you asked that question. Hey everybody, now I've got the technical difficulties accounted for. This is what happens when you've got too many competing things working with the video feed. But you all see me now, right? I'm off center because I'm trying kind of a personal studio at my office at this moment. This is the Planetarium website. What were you looking for?
That's the part that's not displaying the same for me.
Really? So this is not open up right now? Really?
You want me to share it?
You know what? You're welcome to. Go for it.
This is also a way for everyone else to get a tour of our website here. And I'll just share that screen.
Oh my goodness. That is so interesting.
It's strange. Now this is with Edge.
Oh, so it's Microsoft's
fault again. But also on, I had the same thing happening on Chrome.
My goodness.
So let me paste it into Chrome. The whole same thing. The whole reason. See, there's down here. This will change to the different. It says events calendar now, but it'll change to the resources. And yeah, it's the whole reason I tried it on Edge was because it was like that on Chrome.
It sounds like you should send a strongly worded email to Studio 51.
I do. So
to Studio 51, they're okay with that?
I'm going to go ahead and just share the links for the resources page directly as you go through your talk.
If you'd like, I will put the copy address in here for what you wanted to do. I have started recording this, so anything you folks say, we're going to be saving this for posterity and potentially in the future posting this to YouTube or Facebook Live. I think Waylena has already stopped recording, and so I'm going to go back and spotlight myself. And I'm also going to switch out my view from what you're seeing at the moment. You are now seeing me in front of a green screen that I've set up in my office. Hi, everybody. I'm Erik Johnson. I'm the director of the Starkville Planetarium. Welcome to our first Fall Prairie Skies of the season. We do these right now as we're going virtually. We're doing these every other week because both Waylene and I tend to run these shows together. If this is your first time attending one of these, I tend to give a tour of the night sky, and I let Waylena jump in with points she wants to share or to check with questions, because as you know, when you're giving a presentation, you might not be able to look at the group chat. So if you folks have questions, throw it into the group chat and Waylena should be able to respond really quickly. And she'll throw in some nice helpful links as well. Before I get started with our full show here, I wanted to share a couple of interesting things that I use whenever I'm doing observing. The last time we did one of these shows, I talked about the website Heavens Above. You can see that there right now. And what's cool with the Heavens Above, you can actually see this interesting image of Earth's globe. And there's a little instrument right there of note. That is the International Space Station. And it's showing us it's in the North Atlantic Ocean right now. The reason why that's important to consider is that in about 60 minutes, the ISS is actually going to pass right overhead. That orbit you see takes it right over North America. So if you folks step outside tonight, and I think we got pretty clear skies, you should be able to see the ISS pretty low in your southern sky. A good website that you can see this aside from using Heavens Above, I'm going to take you to another website I learned about only about a year ago. It's called Astrospheric. Astronomers, both amateur and professional, love using this website to see if the sky viewing conditions are going to be good over the next about 48 hours. This top bar here shows you roughly the amount of cloud cover we are going to get at a certain hour over the next 2 days. Like at 8 o'clock, like what I was just saying, there it tells you cloud cover is 0%. The second bar tells you about the transparency. Maybe you learned about all the smoke we've had in the atmosphere recently that's come to us from all the wildfires out west. Well, the transparency has been really affected by all of that smoke high up in our atmosphere. It hasn't affected our air quality that much because it's over a mile overhead, but nevertheless, the astronomers have hated this. And the seeing conditions are also another very important component for doing observing. So this is showing us that we've got pretty clear skies over the next 48 hours. I believe we're going to get some rain late on Sunday, nevertheless. In addition to this, notice this little symbol that I've got right here with my cursor. That's, again, the ISS right there. If I click on that, it's going to show you the exact path of the space station going overhead. This here is kind of a fisheye view of our entire sky overhead. The very center of this circle is the point that we call the zenith, which is the point right over your head. I'm pointing at my zenith right now. I can't see you in the cameras, but you could do the same thing. You just point directly over your head. That's your zenith. And you can see that the ISS will come up over in the northwest and pass pretty low in the northern horizon. So not the southern horizon, I got that wrong. And then it will suddenly disappear right over here in the northeast. Reason why is because at 8:14 or 2014, if you use 24-hour time, the ISS is going to pass into Earth's shadow. From the perspective of those astronauts, the sun is actually setting, is the idea from their point of view. Okay, so even though they're 400 kilometers or about 250 miles over our heads, they still see the sunrise and sunset. It just happens every 45 minutes. Pretty quick, huh? All right, that's what happens when you go 17,000 miles per hour. Okay, so yeah, that was just a neat thing I wanted to share with you folks. Now let's finally turn over to Stellarium. All right, hopefully you all can see what I'm going for with this. Yep, and you see me in the upper right-hand corner with my little green screen behind me. Now, with this sky that you're seeing here, I've set the sky to what we would have around noontime. Right over there is the Starco Planetarium. You see we're in the middle of our circle drive. We're on the west side of the Parkland campus at this moment. And this is a nice 360-degree view of what we would see on a pretty good clear day when the leaves are still on the trees. Speaking of leaves on the trees, well, you already know this is fall, right? So those leaves won't be up there for very much longer. I can change in Stellarium where we are viewing from, as in like what landscape we have surrounding us. So I'm going to go ahead and do that so that you can all get a good sense of this. Oops, I've got the wrong one here. There we go. Currently, we've got the Starco Planetarium. I'm going to take us outside of town because, as you're well aware, you get a lot of light pollution in the middle of town, and that can affect how many stars and constellations you can see in the night sky. So we're going to go out to the Champaign-Urbana Astronomical Society Observatory. They renamed that the Prairie Winds Observatory a couple of years ago. So that's what you're about to see here in just a moment. There are far fewer trees out there because it's in the middle of farmland. The only buildings are nearby farm homes and also the buildings that house the telescopes owned and operated by the CUAS. That's what you can see from this angle right here. It looks like it was nice, recently mowed too. I believe Waylena took these photographs a little bit earlier this year, and I think we even have these photos available for you folks to potentially download. I might see if I can share these images with the public if they want to have them. Nevertheless, so here is our sky right there. Pretty empty. It's kind of hard to tell exactly what direction we're facing, but I can give you a nice clue. Right there's the sun, and this is the sky around noontime. So that tells you that the sun would be in the southern sky. Notice now I've got the S a little bit below the sun right there, okay? Now, us passing from summer to fall. This is because of a couple of very specific astronomical concepts, and I wanted to take some time to share that with you right off the bat. First off, the sun appears to move through the sky over the course of the year, over the course of Earth's orbit around the sun. So you see different constellations all throughout the year. Now I'm going to do something a little crazy right here. I'm going to show you a bunch of artwork. All right. I think I'm missing one. Whoopsie. All right. You folks are now going to see me kind of break character here for just a second. Let's get that fella in there. Perfect. Okay. So you see a bunch of artwork in kind of a line right there. Let me take away the ground and you can see that this goes in a complete circle all the way across the sky. You might recognize a couple of these shapes as a matter of fact. You can see the twins there, that's Gemini. You see the crab, Cancer, Leo the lion. The sun apparently is in Virgo the maiden. You see Libra, the scales, Scorpius. You see Sagittarius, the centaur archer, Capricornus, the sea goat, Aquarius, Pisces, Aries the ram, Taurus the bull, right there. These folks are the constellations that you know as the zodiac, all right? And the sun actually moves through the zodiac over the course of the year. There is one other constellation that the sun appears to go through in this path that I didn't show quite yet, and here I'll click on it to bring it up too. It's Ophiuchus. So if you've heard about 13 constellations in the zodiac, that snake handler right there is the last one to consider. So the line that the sun moves through over the course of the year is called the ecliptic, which you can see up there now. And that path is also followed by the planets, and it's also followed by the moon. Not precisely with all those objects, but pretty close, okay? You can see the moon right down there, and you can see a couple of planets right next to the moon tonight, as a matter of fact, okay? And there's another planet right there too. If you wanted to see their names, there you go. That kind of gives it away. So yes, that is the path that the sun takes throughout the year. Now, I did have a point with this, and I'm getting there, I promise. There's another line that astronomers also are aware of, and let me see if I can bring this up correctly. It's called the celestial equator. If you take Earth's equator and project that up into the heavens, you would have a line going across the sky called the celestial equator. You can do the same thing with the North Pole and the South Pole, and that would give you the North Celestial Pole and the South Celestial Pole. That's where we get Polaris from, because it's by the North Celestial Pole. And what's significant about this is that look at where the two lines cross. The ecliptic goes through here and the equator goes through there. And a couple of days ago, the sun actually crossed the celestial equator. And now from this point forward for the rest of the year, the sun's light is now going to favor the southern hemisphere. And that coincides with all of our temperatures getting a little bit cooler because we're going to get less sunlight, and the sun's not going to get as high each and every day, okay? So that changing position of the sun over the course of the year due to Earth's orbit, and also because of Earth's tilt, that's what causes our change of seasons, okay? So you can now see why we keep track of those constellations in particular, and why the equinox was such an important day, all right? There's some major seasonal shifts going on with the sun crossing that celestial equator. All right, I'm gonna turn off all of that stuff. Thank you for indulging me on all of that information right there. Let's go ahead and watch the sun go and set over in the western sky. All right, you see it's very slowly moving there. I'm making it move a little bit faster now. And this motion is just being caused by Earth's rotation. All right, oops, something was clicked there. Here's another component of the equinox. Let me turn back on the cardinal directions here. Notice that the sun is setting almost due west. On the day of the equinox, the sun actually set due west and rose due east. And that's something that you can track anywhere on Earth. And people have done that for thousands of years. That's where we got our Stonehenge from, right? And if you want to build your own Stonehenge, you're more than welcome to do that with whatever materials you have around. And all you have to do is just track the sun every day and see where the sun rises and sets. okay? You could build it out of cars like that guy in Western Nebraska did too, okay? So let's go ahead and watch the sunset here. All right, we see it's a lot darker now. This right after sunset here, you're seeing a lot of stars, and that is just because I wanted to make sure they were nice and visible even through Zoom. So hopefully you can see lots of little dots in our twilight sky right here. There's one really bright star right above the west, and I think I just want to talk about that one in about a minute here. So I will talk about that in just a moment. So just to the right of that really bright star, I see a recognizable group of stars here. Let me see if I can select this correctly. We will see what happens with this. All right, so in this case here, you are seeing a lot more than what I would normally identify with this group of stars. Perhaps when you were
Erik,
looking.
can I interrupt you for just a moment?
Of course.
Are you going through OBS or are you screen sharing?
I've got OBS. I'm sorry to hear that.
Could you switch to the screen sharing? Yeah.
Sure. I'll switch over to screen share. I'm sorry.
Thank you.
Apparently, I'm really taxing my network. Thanks for letting us know. All right. We'll play with this instead. And plus, what's really fun with this is that I can annotate. I always love doing this. Here we go. Sorry about the technical difficulties, folks. Apparently, with my computer, it can only take so many programs I'm running at once. So I try to run these from campus so that everybody can see this pretty clearly. All right, so you folks see a group of 7 stars right there. That is the Big Dipper, okay? Now, we call that the Big Dipper here in North America, but other cultures actually give very different names for this group of stars. If you have a friend from Britain, they're actually probably going to call it the Starry Plough, okay? People in Northern Europe, they refer to this as Charles Wagon or Karlswagen, okay? And you hear the term wagon being used in other cultures, actually in other parts of Europe as well. But it's pretty amazing to see that lots of people have seen this group of stars over time, but they all have different names for it. Now, let's see here. I'm going to stop my annotation for a moment so I can do this. So the 3 stars here at the handle of the Big Dipper, notice they're kind of curved. They're curved like a circular arc. And what's great about that is that that helps you a lot with remembering the name of this star, Arcturus. We just followed the arc to Arcturus right there. Now, you're not going to be able to see Arcturus that much this evening because it will set only a couple hours after sunset, but nevertheless, this is a kind of a spring star, but I wanted to give you one last view of this before we lose it for the end of the year. And you can catch it, next year as well. But you'll be ready because you'll follow the arc to Arcturus. So astronomers use clues like this to help them organize the sky. You just saw me follow the arc to Arcturus right there. Another nice one is where we take the 2 stars opposite of the handle of the Big Dipper and we draw a line with them. Well, I should draw that line, shouldn't I? Here we go. We'll draw that line and it leads you pretty close to this star right there. What we've just done is that we have pointed to Polaris. Okay, let's see if I can get this up correctly. There it is, Polaris. And Polaris, as I mentioned before, is our North Star. As we go later into the night, you see that all the stars are moving around there. Here, I'll go a little bit slower there. You see stars are setting over here in the west. The stars over in the eastern half of the sky are rising. The stars appear to move around and around Polaris, but Polaris stays in basically the same position over the whole evening. And that's why it's called the North Star, because it's always pointed in the north. All right. This time right here is at about 9 p.m., a few minutes before, and I see some bright things over here in my southern sky, so I wanted to focus on them. One of them you can probably see pretty nice and clearly because I magnified it a little bit. It's this guy right here. I'm going to go ahead and zoom in on it so you get a good view of it too. All right, so you all can probably tell that you're looking at the moon right there. Have you seen the moon over the last couple of nights? We've had some clear nights, so maybe you've been able to catch it. This moon looks maybe a little bit different from what you saw over the last couple of days. Maybe you saw this on Wednesday and it looked like this. Maybe you saw it on Tuesday or on Monday right there. okay? So what we're seeing today is more than half of the moon's disk right there. You see the same side of the moon is facing towards us. It's just that more of it is lit up. This is the moon going through its phases. We saw a crescent moon earlier this week. Yesterday was first quarter, and I am yesterday right now. There we go. That's what we're seeing today. This is a gibbous moon. When the moon is rounded on both sides, that's where the term gibbous comes from. And since the moon is getting brighter and brighter each night, it's waxing in this case. So we're seeing a waxing gibbous moon right here. And if you continue observing that over the next couple of days, you'll see the moon get fuller and fuller. So we'll have a full moon midway through next week right there. All right. Now, we see a couple of really bright dots just to the right of the moon. And there's something else that's actually sticking out with those two bright dots. If you look really closely at what we're seeing in Stellarium here, you can see the stars up there happen to be twinkling. Look at the stars below and to the right of the moon. This blue star here and this one here, it's really flickering in brightness. If you can't see it, I can always make it really amplified here for you all, but you are seeing some twinkling going on. Because of how badly my view was working with this earlier, I'm just going to make this a little bit better for you all. So we'll go up to 0.5. There, now you folks can really see it twinkling, okay? It's a very sparkly sky up there, isn't it? Okay? But notice those two brightest dots are not twinkling. And the reason why is because those are not stars. These objects will twinkle a little bit, but not nearly as much as the stars do, okay? It takes a lot to get them to twinkle. And that's because those two objects are in our solar system. They're planets. And let me see if I can get this correctly to point at them. There we go. Let's zoom in on this first one, the brighter of the two. All right, so we've zoomed in pretty close. I see a bright dot to the left of that, but then I see this one is now a circle, or a disk, usually is the term we love to use for this. And I see that disk has some stripes to it. Let's investigate closer. Oh, wow, look at that. Looks like we're looking at clouds over this. Folks, you are looking at the planet Jupiter right there, the biggest planet of them all in our solar system. It's a humongous planet. It weighs over 300 times the mass of Earth. I know I just mixed up weight and mass. I'm sure my science teachers in the audience are just really busting an artery in their head or something. Just aneurysms all over the place here. They know that term. All right. Now, yes, it's 300 times more massive than Earth. And another good way to get a sense of its size, this time I'm talking about physical volume, look over on the right side. I'm going to go back an hour here. You see that dot right there? That dot has a very technical name. It's called the Great Red Spot. Sounds very technical, right? Yeah, I know. That there, well, if you're looking at clouds all over the surface of Jupiter, that means that that's a hurricane. And it's a humongous hurricane. That hurricane is bigger than our planet. Yeah, bigger than Earth. A whole storm bigger than Earth. That's what you're seeing right there. And it's been there for a long time. The Great Red Spot was first observed in the 1600s. So it's a long-lasting storm. I mean, a storm lasting 3 centuries, that's persistent, okay? Where was I at? I was there, that's right. And let me zoom back out just a little bit here so you can see some other interesting things. Let me see if I can get this going. Right next to Jupiter, if you look at this with a telescope, do I really only see one there, Waylena? I'm not missing the others, am I? Oh, I know what I did. I know what I did. Don't mind me, folks. Don't mind me. I made a setting change and made it so that the other moons were invisible. That's my embarrassment you're seeing over there in the upper right. When Galileo pointed his telescope towards the heavens, he discovered lots of interesting things. When he pointed it at Jupiter, he found 4 dots that appeared to follow Jupiter as it wandered among the other stars in the sky. They would change their positions, sometimes leading Jupiter, sometimes trailing Jupiter. And he determined that they had to be moons orbiting around Jupiter. Eventually, they got the names Callisto, Ganymede, Io, and you can't see Europa because that's right behind Jupiter there, but you can see at least 4 dots. There we go, there's Europa. But those there have now been named the Galilean moons in his honor. And even with a small telescope, you can find those moons orbiting around Jupiter, okay? And they're pretty bright, but apparently when I changed my settings earlier, I turned them off. Sorry about that, everybody. So here we go. Let's go ahead and zip back out here. Explains why I couldn't see it, huh? All right, let's go to that other dot just to the right of the moon and to the left of Jupiter here. Here we go. And we'll zoom in on this. And I bet you'll know exactly what this is when you get a closer view of it. Because how many planets do you know have as beautiful ring system as this? Probably my favorite planet to look at through photographs. And I really thank the Cassini mission for orbiting around the planet Saturn for about 13 years, giving us so many beautiful photographs. But Saturn still looks really nice from Earth. When I point a telescope at Saturn sometimes, you get a lot of people seeing it for the first time who think you just put a sticker on the eyepiece. And trust me, I don't have stickers that look that good, okay? That's just what I have to tell you. But yeah, Saturn right there has those beautiful, gorgeous rings. There are thousands of rings there. And they're really, really thin, folks. There are times when Saturn is pointed in such a way that the rings actually basically disappear because they're less than a mile in thickness, okay? So yeah, they might be 100,000 miles wide, but they're only about a mile in thickness. Very, very thin rings. With an outer view of Saturn here, I think I have it so that you can't actually see the moons around it. So I'll do this just to save myself on this case. And there's a little dot right there. That is probably its largest moon, Titan. There it is. Okay, just had to make sure I was right about that. And I've gone and lost my Saturn. That's okay. All right, so it's almost 9 o'clock right here, and you've seen some interesting objects in the solar system, and I showed you the Big Dipper. I'm now going to point the view here almost straight overhead. We're going to go up to that point that we call the zenith. You might have noticed that we're kind of also following the Milky Way right there. Can you see the Milky Way? If you cannot, I will cheat and take away our atmosphere. Everybody hold your breath. Oh, sorry, I can't do it very long. Okay, so there you can now see the Milky Way without our atmosphere making it so much dimmer. The center of the Milky Way is right over here in the constellation of Sagittarius. So you might hear about things when, hear the term Sagittarius being used when you hear about the black hole at the center of the Milky Way right there. So let's scroll up to the top here, and the Milky Way is going right overhead. Late summer and early fall are a wonderful time to look at the Milky Way right after sunset if you've got clear, dark skies. And there are 3 bright stars up here right along the Milky Way. The one to the right here, the brightest of the 3, is named Vega. Let me see if I can get this correctly. You see Deneb up there in the middle of the Milky Way, and on the opposite side of the Milky Way, you have Altair. And I always like to give a shout out to one of our fellow astronomers in the Champaign-Urbana area, actually my predecessor, Dave Leake, and that's because look at the initials of these stars. Deneb starts with a D, Altair starts with an A, and Vega starts with a VE. So if the summer triangle isn't memorable enough for you to remember the names of those stars, just remember that it's called the Dave triangle. Really nice and useful right there. Now, even though that group of stars is called the summer triangle, they're actually all part of separate constellations. Notice this right here. Vega seems to be part of this tiny little constellation. Deneb, it seems to have the Northern Cross in there. Both of these actually look kind of like, oh yeah, I guess they are birds. Yeah, Deneb is part of this swan that you see there, and Altair is part of this eagle. And the names of these constellations are just the Latin words for each of those. Cygnus is the Latin word for swan, and Aquila is the Latin word for eagle. And Vega happens to be in a nice little harp that you hold in your hand called a lyre, which in Latin is called lyra. So those are the 3 constellations whose bright stars make up the summer triangle. And I'll share with you one other constellation up here because I saw somebody in the audience who probably also is a big fan of this constellation too. Let me turn these off so it doesn't give it away right off the bat though. Just to the left of Altair is a constellation right here. It's a tiny little one. You see a tiny little diamond there, and apparently the diamond's on a string right there. But this is one of my favorite constellations because it's so tiny. It's easy to see though, and its name is Delphinus. You might not know what Delphinus means in Latin, but this artwork will certainly help you out. It's a dolphin. Don't you love dolphins? That's why Delphinus is my favorite constellation. It's just because I love dolphins, all right? There's no good reason for it, but you don't have to justify your favorites, right? Okay, so just wanted to share that with you all. All right, let's go ahead and zoom back out here. I think, yeah, there we go. We're gonna go ahead and move over to the eastern sky. I said this is at about 9 o'clock. See lots of twinkling stars up there. And then I see one other object that appears to have not as much twinkling at all, okay? And that last object right there, I'll click on it and show it to you. It's very low in the eastern sky. You notice it's got kind of a beige, maybe a reddish tinge. As we said, if it's not twinkling, you're probably looking at a planet right there. Let's look at it up close. Oh yeah, that's a disk right there. That is our red planet. We're looking at Mars. And you see two dots right next to it. Those might be stars or those might be its moons. I'm not going to click to find out right now. That's okay. But yeah, Mars is coming up in the sky right after sunset. Mars is actually getting pretty close to Earth right now. You see the distance over there on the upper left? It's about 42% of the distance to the sun right there. And it's getting ever closer. Mars is coming to a point where it'll be really bright, really big in a telescope. You will have no trouble seeing it in the evening skies this fall. We call that its opposition because it's in the opposite place in the sky as the sun, all right? We would set up some nice public viewings for this, but pandemic, all right? So nevertheless, I encourage you folks to step outside and look for Mars in the east in the evenings this fall, okay? And if you think this is too late, because this is 9 p.m., it'll be up earlier over the next several weeks. And at future shows, Waylene has got lots of other cool things to share about this, okay? There, she put her thumbs up, so that was a promise. You gotta hold her to it now. Okay, let's see here. Let's go ahead and go a little bit later now.
Eric, while you're advancing through time, I'll point out that although these prairie skies are pretty much every other week, next weekend we will be having a special edition 8 p.m. Prairie Skies right after our Kaler lecture talk, and I will be giving that Prairie Skies 8 p.m. next Friday, and we'll have a lot of stuff, but Mars will be a huge part of it.
Oh yeah, Mars is going to be a real highlight this fall, especially in our shows. Okay, now before I go even farther, I see something really interesting up here coming up a little bit north of east, okay? I see what looks like a nice little tight cluster of stars right there. And what's neat about that one, let me see if I'm paused completely. Now I am. This is a little bit after 10 p.m. If this is too late for you, that's okay. Just wait a few months. You'll be able to see it then. Okay. So what you see, this little tight cluster of stars, I've heard some people tell me they're thinking they're looking at the Little Dipper right there. It is kind of a tiny Little Dipper. But usually when I'm looking at this, I don't think of seeing just a dipper, but I do certainly see 7 stars, maybe not with my own eyes. And of course, when I get a set of binoculars or a telescope on it, I see lots and lots more. There are over 1,000 stars in this cluster that we can find here. You are looking at a group of stars that we refer to as the Pleiades. You might also hear it called the Seven Sisters, and it might even go by a couple of other names. And let me see if I can get this up correctly here. One of them will sound kind of familiar to you. This group of stars is known to the Japanese as Subaru. So the next time you find a car that's a Subaru, look at its logo, the marquee. You'll see 6 stars on there, and that's because that company was formed by a merger of multiple companies, and they decided to take from that merger this metaphor that they got from how they see the Pleiades. Subaru right there, okay? Just something, some fun bit of trivia I wanted to share with you all there. Okay, let's go ahead and zoom back out. Pleiades are a wonderful object to look at through binoculars. I honestly don't recommend looking at it through a telescope because it takes up so much of the sky. It's actually a lot wider than our moon in the sky, so you'd have a hard time seeing it if you're looking at a really magnified view. Okay, just one recommendation. Another one of those objects that's really great in binoculars, it's a lot higher up at the moment, but I do want to share that too. If I look up way high in the east here, over on the left side, I see a nice group of stars that forms a W here, all right? And let me see if I can get this correctly. Oh yeah, lots of things up there that I've shown. So there's our W right there, and this W is meant to represent, ooh, there's everybody, okay. That's always fun. Let's see if this does this correctly now. There, you see it's a woman sitting on a chair, or really a throne, because that's the queen known as Cassiopeia, okay? Now, she has a daughter who's in a constellation right next to her, and her name is Andromeda, right there. Andromeda doesn't look like she's in too good of a state. You see her arms are wrapped in chains. That's because she was gonna get fed to a sea monster until she got saved by Perseus. And he actually flew in on Pegasus, the winged horse right there. Perseus is over here, as a matter of fact. Now let me go ahead and turn off all of that stuff. Now the main reason why I wanted to show this to you is because in the constellation of Andromeda, oh, I missed it. Oh, I'm not getting it, so I'll have to zoom in just a little bit more. There we go. There's an object that you can see with your own eyes under really clear, dark skies. But like I said, it's better to look at using binoculars. I'll see if I can zoom in on this properly. There we go. You see a spiral galaxy. This here, it's the galaxy in Andromeda. So therefore it got the technical name, the Andromeda Galaxy. Okay. You see up there, it says Andromeda Nebula. That is because it was not until around 1920 that astronomers knew for certain that this object was actually outside of the Milky Way. The reason why they found out it was because they were finally able to calculate the distance to it. And this thing is 2 million light years away from us. So when you look at this faint bit of light in your night sky or with binoculars, you have to imagine that that light traveled through space for 2 million years before it got to your eyeballs. Now, yeah, that's a long time. By comparison, the stars that I was showing earlier, stars like Vega, well, that light, it only traveled for 25 years. So it's only a few trillion miles away. That's nothing, okay? I know. It's ridiculous to conceive of how big space is, but I just wanted to bring that up. Okay, let's go ahead and go back later. And maybe I'll bounce it up by a few hours here. There you can see a nice little V. Oh, there's the constellation Orion coming up pretty late. I assume that 1:16 a.m. is past your bedtime, isn't it? I know it's past mine, although sometimes I'm maybe up that late. Tisk, tisk. All right, but yeah, you can see Orion coming up over here in the east. We'll go a little bit later. I think Venus will be up in just a few moments. All right, oh, there it is. I can tell it's right there. Especially because note, once again, not twinkling. There you go. Venus is right here. If I zoom in on Venus, I don't see all of Venus there, do you? No, I see Venus looks like it's a little cut off. Kind of looks like how the moon does. Remember how the moon has phases? Well, Venus shows phases as well. So does the planet Mercury, but Mercury stays too close to the sun for us to get a good look at it. But Venus, if you can get that one in a telescope, you can easily see Venus goes through the whole cycle of phases. So Venus is kind of showing you a gibbous shape right now. Really cool that it does that. Venus also changes its size and how it looks to us because it changes its distance from Earth so much. It's a really neat object to track over time with a telescope as it goes around the sun. All right, so this is the sky at about 4:16 a.m. Whew, we are getting up really late here. Okay, so yeah, exactly. Yeah, this is the part where you really are rubbing your eyes because you're just so tired. Did I turn off the atmosphere? No, it's twinkling. The atmosphere has to be on. Okay, There we go. Oh, look at that. There's our twilight. So now at this moment, we'll check the time one last time. This is at about 6:30 in the morning. Notice that because of all of that sunlight coming into our sky, we've lost almost every single star. The only ones left are the brightest of all of our stars. And we do see a couple of planets. I'll look over to the right here. We'll check to see what planets are in view there. That's actually Mars over in the west. That means that the moon, Jupiter, and Saturn set a while ago. So we've only got Mars and Venus up by this hour, okay? And now we'll let the sun come up all the way, and even Venus is gone. So the only one left is the sun, all right? At least until the moon comes back up. Okay, so it's now 9:30 tomorrow morning. Man, oh, what a long day. Hopefully you folks are ready for a nap. Okay, I'm gonna stop sharing so that you can go back to my lovely face. There I am. Okay, and it says my speaker is not working because I'm taxing my network. That's always fun. So, folks, I hope you enjoyed our little tour of the night sky. Feel free to unmute yourselves and ask us any questions that you might have.
Say, Eric,
Yeah.
could you tell folks about big astronomy?
Oh, absolutely. I'm so sorry. I did not bring this up right off the bat. Thank you for that. I will be happy to share that because there's a lot of cool events happening tomorrow. Okay. So you might like to deal with some more astronomy tomorrow. I'm going to bring up the website so that I can share it that way. Okay. It's loading. Come on, network. Okay. So there is a planetarium show that we have recently acquired and is going to be giving its worldwide premiere tomorrow afternoon, okay? There will be shows in the evening and also in the middle of the afternoon to watch. Since we cannot actually show this in our own dome, we're trying to promote these live stream events that they are holding throughout the day tomorrow. Now, it is a full dome show, and you don't have a full dome at your home, I assume, but what they are doing is they are offering to everybody a way to watch a 360-degree video using various things like Google Goggles, okay? Or you set up Google you set up Google Cardboard and watch and pan around with your phone to look up at that video. And there are other ways where you can just watch a live feed with YouTube and use your mouse to drag the screen around to look at different portions of it. Today, I posted a link to those live streams on Facebook. And I don't think I have that Facebook link up, but did you share any of these links in the chat?
I'm about to. The Facebook link for their event site, but also the YouTube link where they'll be actually broadcasting it tomorrow. And if you go to that YouTube link right now, it shows when it's going to go live.
Okay.
And we should also point out that when we are finally able to celebrate astronomy together in the planetarium, we will be showing this program, and we are so looking forward to sharing it with everyone.
Absolutely. If you can still see my screen, oh, I got to go a little higher there. This shows you the times when the film is going to be streaming. Like normal planetarium shows, this will be less than an hour. So you see a stream of the film happening at 2 p.m. Central Daylight Time in English. You'll have another one live in English at 7 p.m. tomorrow night and at 9 p.m. tomorrow night. And for those of you who are native Spanish speakers or people who love to watch videos in Spanish, they'll have a stream of this film in Spanish, which I believe is, you're going to go ahead and critique my pronunciation here. Big Astronomy is going to be in Spanish, Astronomía a gran escala. Okay, and that will be the stream in Spanish at 4 p.m. tomorrow. We'll
Eric,
also have some.
Eric,
yeah.
could I get you to share it through a screen share?
Oh, okay. We're having one of those issues again.
It's blurry.
I'm so sorry, folks. I really wish that I got OBS to behave better for me. I like it a lot, but it seems to not want to play nice with Zoom. There you go. You can now see that a little bit better.
Awesome.
Thanks for your understanding, everybody. But yeah, you see the times there, and do have links to all the YouTube stuff. I'm on bigastronomy.org for you all to check that out. Okay, and they've got a neat educational activity demonstration at 5 p.m. tomorrow too. Okay. All right. So yeah, do you folks have any questions or observations you wanted to make?
I do.
Okay, was that was
Who is that? Yeah.
I am Kate. Kate Mullen.
All right. And you have a question for us?
Yes. How many stars are in the galaxy?
Awesome question. Yeah. Unmute yourself, Erik. Yeah, you're still muted, Erik.
how did I mute myself? I don't know how I did that.
I don't know.
Okay.
Ghosts are weird.
Yeah. All right. So the number that I usually like to share with people is 100 billion. Okay. Might be a bit off, but that's at least gives you a sense of the magnitude. Now, 100 billion, that's 1 followed by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 zeros.
Wow.
Yeah. Yeah. Gosh, Waylena, are there more stars in our galaxy than there is grains of sand? Maybe not. Maybe there's just more stars in the universe than there are grains of sand.
That for sure.
That one's
Yeah.
probably right. Yeah. Yeah. More than the number of grains of sand in all
On the Earth, at least.
on our beaches. Yes, on Earth. Yeah. Yeah.
We don't know beyond that. Yeah.
So much.
Absolutely right. But oh my gosh, there are so many stars. Okay. It's reasons like that that make me think we cannot be alone, because there's so many opportunities for life elsewhere. I'm not saying I can guarantee that there's life. I'm just saying that the opportunities are there.
Do aliens live on them?
Potentially. A lot of situations it might not be possible, because there's a lot of stars where you probably don't have life on those worlds. When you've got some really big stars, they don't live a very long time. They might only live for a few million years. Our sun has been around for 4.5 billion years, okay? And that's how long it took for us to show up, okay? And then we started trashing the place. Oh, I'm sorry. But yeah, it took a long time for us to get here. So, but we've had life on Earth for quite a while, just different forms of life. And I would say that there are a lot of stars out there that have been around long enough to have life. And that's why I think it's a great opportunity for life to exist elsewhere, even in our solar system. I mean, in our galaxy. I don't know why I'm not saying those words correctly. All right.
So it looks like Elliot has a question.
I see a hand raised from the Beatty family, and I'm trying to unmute them. And Elliot, go ahead and fire away.
My question is, are all the stars in the night sky that we can see in our galaxy?
Yeah, basically. A lot of them are actually really, really close to us compared to the rest of the galaxy. You heard me give some very big numbers. Our galaxy, and I don't have a model to share with you for this right now, our galaxy is 100,000 light years across. But then when we talk about the stars that you see in your night sky, none of them are more than a couple of thousand light years away, okay? They're pretty much all in our very close neighborhood. We have some really neat tools to show in the planetarium to give a sense of how this looks and how all of them are in our close vicinity. But I don't know if I've got one here on my laptop, on my computer here, that shows this really well. I'll
make sure to adapt that demo for when we start streaming from the dome.
Absolutely.
I'll make sure to adapt that demo.
Elliot, here's what I'm going to try to do to try to illustrate this. You remember how I showed you the Andromeda Galaxy? All right. And let's bring up the Andromeda Galaxy one more time here. There it is. That'll work.
I actually have another question.
Okay, Kate, let's hear it.
How many galaxies are known?
Oh, so there are two ways to answer this one, and I'll try to not get too into the weeds with this. Based on how dense the universe is packed with galaxies, in the part of the universe that we can see, we know about there being 100 billion galaxies. That's at least the number that I grew up with. So yeah, remember how I was telling you about how the Milky Way has 100 billion stars? Yeah, well, there are 100 billion other galaxies like that. Ugh.
There could be a lot more. I'll tell you what,
yes.
I'm quite a bit older than Erik is, and the number of known galaxies was smaller when I was growing up. So every year we're discovering more galaxies. It is so awesome.
Yeah, the other problem with this is that we see galaxies merging all the time. When we look back earlier in the universe, we saw that there were more galaxies, and what's happened is that they get closer together and they merge to form bigger galaxies. And that's something the Milky Way and the Andromeda Galaxy are going to do in the near future, okay? And by near future, I mean a few billion years. Sorry about that.
Yeah.
Yeah, in a few billion years, the Andromeda Galaxy and the Milky Way are going to merge. They already have a name for it. It's Milkomeda. I don't know if the galaxy's okay with that, but that's what they're calling it. So that means that they've revised that estimate. They now say that they're actually among the part of the universe we can see, there are over 1 trillion galaxies. And remember, I keep telling you the part of the universe we can see. There's a lot of universe out there that we can't see. In fact, that means we don't know how much is out there. So the number could essentially be infinite. All right, I'm going to go back to answering Elliot's question. I'm going to see if I can draw this out. All right, you remember the Andromeda Galaxy? We all love it. The Andromeda Galaxy, you'll often see pictures of the Milky Way in like on t-shirts or online, and they'll actually just be using a picture of the Andromeda Galaxy because people are sneaky like that. No. Okay, oh well.
Plus, we can't get outside our own galaxy to take a picture of it.
Exactly. We just don't have the sense of perspective. All right, I'm going to give you a circle right now. Do you see my tiny little circle?
Yes.
That gives you a pretty good sense of what about a few hundred light years looks like. Okay, I'll make the circle a little bit bigger. This circle probably covers every star you see in the night sky. Probably.
That's a lot.
Yeah, so you see thousands of stars in the night sky, but they're all in that tiny little circle. Okay, so it's showing you that among the stars you see in the night sky, they're basically all in our neighborhood. Okay, but they never come over to visit. It's really a shame. But yeah.
Everything we see in our night sky too is a part of our galaxy except for other galaxies.
Yeah, exactly. And the Milky Way is, the Andromeda Galaxy is probably the only thing that you can see without a telescope or binoculars that is outside of our galaxy. It's, I guess you have a couple of others, the Magellanic Clouds, but we never talk about them because they're so far south. So, yeah.
Around city lights though, around town, even if you've got pretty good skies, binoculars help a lot for seeing the Andromeda Galaxy.
Absolutely.
I have another question actually.
Okay, Kate, let's hear it.
Okay, how many years old are all the things combined? Like everything in the solar system combined, how many years old is all that?
I would say that pretty much everything in our solar system is roughly the same age. All of it is about 4.5 billion, with a B, years old. So that's 4.5, 5, right? 4, 5, and then 8 zeros after it. Okay.
I don't think my calculator can take that.
Yeah, you're probably right. I know that if I'm using the calculator on my phone, I have to tilt it sideways to take those numbers. Okay. Yeah, definitely. It can be a bit of a challenge, but yeah, you can just try to write that number down and go, oh, wow, that's a big number. Okay.
Run out of room on the page, and you have to start making those zeros smaller and smaller when you get to the end.
Yeah. I mean, here, I'll give you a sense for this. The number of people in the world right now is just a little bit less than 8 billion.
Wow.
Okay? And so that means that you give each one of them one of those years that our planet's been in existence. And well, I guess that would use half of the people on Earth.
I'm really good at math, but I don't think I'm that good at math.
Give it time. I'm sure you'll do great.
I'm just in 2nd grade. That's nothing.
You'll get to bigger numbers, I promise. It'll be fun.
Oh yeah.
Thank you.
Yeah, thanks, folks. Any other questions from anybody here?
I have a question.
I do.
And in the south sky every evening this summer, there's a bright light. We use one of those apps to try to figure out, you know, if it's one of the planets or whatever. And it's like the first bright object you could see after sunset, and it's slightly up over the trees in the south sky. And I'm just wondering, are satellites bright enough? Do they shine light that it would be acting as if it looks like a star? Because it doesn't name it. I have two star apps or Find the Planet apps, and it doesn't quite zoom in on what I'm thinking, you know, what we see. I keep pointing that out, and look how bright that is. And I'm just wondering if you have any idea what I'm talking about.
Sure. You can have some satellites that get really, really bright, okay? It just depends on how well they're reflecting the sunlight back down to Earth. But they're not going to be showing up at the same spot in the sky every single evening is the only problem there, okay? The only satellites that we have in such geosynchronous orbit are really high up there, and they're giving us our cable television. Okay, so it's not those, but what we do have in the southern sky right now that's brighter than anything else except for the moon is the planet Jupiter.
So it's probably Jupiter then.
Yeah, and the next time you check, maybe you'll see a relatively bright object just to the left of it, and that is Saturn. Okay, Jupiter was right next to the moon last night, and the moon is next to Saturn tonight, so you could check that out. And what, we've got the ISS in only 10 minutes, is that right? So, yeah.
Nice. So if we wanted to go out to Middle Fork, isn't binoculars enough for us to go out there and enjoy? Because we don't have a telescope or anything like that.
You'd have a great time looking with binoculars out there. One thing I like to tell people to do if they have a set of binoculars, and especially during this time when the Milky Way is overhead, is to just take the binoculars and point it at the Milky Way and look at the so many stars that are up there. When looking without binoculars, people look at the Milky Way and like, that looks like some sort of weird set of clouds that aren't moving. But then you find out all of it is stars. That area is just full of stars. And when moving around with the binoculars, you might find a couple of little clusters of stars. And that's always a delight to catch. Okay, so yeah, I think you'd have definitely a worthwhile time. And if you can find things like the Pleiades later at night, or the Andromeda Galaxy, another good one is the double cluster in Perseus. That's right below Cassiopeia. That's a good one to catch. Those are all things that are really high up there that are really cool things to check out.
I have another question.
Hold on one second, Kate, because I saw that there was a question here in the comments. I'm going to turn it to Elliot, then I'll go right back to you, okay?
Okay.
And also, I'm going to post a link to the PDF of our fall star chart for anyone who wants to download that and print it out, because it has some of those binocular things.
All right. Okay, so Elliot, go ahead, and then we're going to go back to Kate, okay?
My question was, I forget.
Oh no! Oh, I'm sorry. You can write it down in the chat if you remember it. Do you remember what we were talking about when we talked about, when you had the question come to mind?
No.
Oh, darn it.
Okay, it happens to me too.
Yeah. I usually
It
try to
happens
ask
to
people about what they were
everybody.
thinking about when they have those questions. Kate, go ahead.
What if another galaxy crashes with our galaxy? Would us humans be okay?
That's a great question. I mean, you hear about these things and we talk about calling it a collision. That sounds really dangerous, doesn't it? Well, the funny thing is, even though you were talking about changing what the galaxy looks like in these events, you are not actually going to affect many of the stars that are in there. They'll be thrown around, and sometimes you might actually have, unfortunately, a situation where planets might be thrown from their orbits if they do pass close to another star. But the space between the stars is humongous. There's a lot of empty space out there between the stars. I mean, the closest star to us that's not the sun is 16 trillion miles away. It's really far, okay? And trillion has 12 zeros after it, not 9 like a billion.
Oh.
Ugh. Yeah, so that one definitely won't fit on your calculator, okay?
What
Yeah.
if the North Star crashed with something?
Well, the funny thing is, we call it the North Star because you saw it wasn't moving, but it's not always going to be the North Star. If you ask the ancient Egyptians, I mean, you know, they're just right next door. It's okay. If you ask the ancient Egyptians what their North Star was, they had this star that we see in the constellation Draco called Thuban, and they saw it as their North Star. Have you ever spun a top around? Okay.
Yes, many times.
Yeah, and remember, when the top starts to slow down, it starts to wobble, right?
Yeah.
My finger wobbling around. Well, that's what Earth is doing. Earth is being tugged at by the moon and the sun, and it's making Earth's rotation, its spin, wobble around. We don't notice it over the course of our lifetimes because that spinning takes 26,000 years.
So
And that
it
means,
starts.
go ahead.
So it starts to topple this way, then that, and blah,
That's
blah,
right.
blah.
That's right. So you will see that thousands of years from now and thousands of years in the past, the North Star was actually a different star.
That wobble happens very slowly, though. It doesn't wobble fast.
I
Like
did
the
say
top
thousands
does.
of years.
Yeah,
Thousands of years.
Thousands of years.
Yes,
So
Polaris.
it goes extremely slow.
Very slow motion.
Yeah, very slow.
Is it as slow as a slug?
Slow as a slug? It's even slower, I bet.
Oh. Wow.
It's even slower than a slime mold.
Uh,
I
Slime
have a
molds are
question.
really slow. Yeah, go ahead, Deborah.
So in the daytime, do you have a way of studying the constellations? How do you know what stars are there during the day? Could they be different than what you see?
Oh, that's a good question. It is very hard to see this stuff in the daytime. But what happens is that over the course of the centuries of looking at the sky, we get a good sense of where the sun is at in relation to the stars, even though the sun's glare is blocking out that, it is overpowering all of that light. Then other good ways to get a real-time daytime check of all of this is during a solar eclipse. If you have a total solar eclipse, you can actually see a few of those stars around the sun because so much of that light is being blocked by the moon. So that's a good way that they can compare that stuff. I know, my software here is cheating, just pulling away the atmosphere, so you can't really tell all that well. But now that humanity has gone into space, we can check parts of the sky closer to the sun at all hours and get a better way to tell where these planets are in relation to those constellations.
Oh, that's interesting.
Yeah.
So I just saw a red thing going by really fast. Would that be the International Space Station, or is that just a plane?
Probably. So a good way to tell all this stuff is whether or not it's, if it's blinking, yeah, it's a plane.
Okay.
If it was very low in the northern sky, that was the one that I was trying to say would be the ISS. And I think I'm going to go back to the website I was showing before. Let's see if I still have it up. Did I close it? Ooh, I closed it. All right, I will
Normally
bring
the
it back
space
up.
station would not be red, but if it's really low, it could look red. And depending on how much smoke and dust and things are in the sky, it could also make it look a little more reddish.
Yeah, and it is really low, but it is reflecting that sunlight very nicely. Can you see my shared screen? The ISS is only coming above the
Yes.
horizon at 8:08 in 2 minutes.
So
And
it's
then
okay.
it will be up for 6 minutes. It'll be probably pretty tough to see for a few of those minutes. But at about 8:12, it'll be as high as possible. And so you'll have 2 minutes before it passes into Earth's shadow then. But as you can see, it's not going to be very high up there.
Thank you.
Yeah, you're welcome. All right. Kate, were you asking another question? Did you have another one for us? Oh,
Well, this has been a really good time here. We got so many good questions. Oh, very, very cool.
I want to go with Jane Donna's question here and address that whole South Star thing. If you folks don't mind, I will share my screen one last time. All right. We're going to do a couple of other fun things with my sky this time. What part of the Southern Hemisphere would all of you like to go to? Would you like to go to Australia, Argentina, South Africa, Madagascar, New Zealand, Antarctica? Anybody?
Madagascar.
Madagascar. Okay, let's go hang out with the lemurs. Hey, wow, it looks just like our observatory. What a shock. Okay, the reason for that is just because these landscapes just are pasted upon our scene no matter where we're at. So let's go ahead and I will just make up a random scene. Yeah, that probably doesn't look like it that much either. I'm gonna just pretend it's the skies that we
Eric,
see.
are you doing screen sharing or not?
I thought it was.
We don't have, I just have a sign that says that you've started screen sharing, but I don't see a screen.
Oh, weird. I wonder why it decided not to be nice. Oh, it says my screen sharing's paused. Why did it pause it?
And yes,
Oh,
it is a
resume
good
share.
point. If anybody that wants to go out and look for the ISS, this is the time. So yeah, you're not going to hurt our feelings if you run out to see it.
Certainly not. Okay, I'm going to take away our atmosphere, and the Milky Way looks better from this part of the world. I just wanted to say that. It's the biggest reason. I mean, why would you want to go to these places aside for just looking at the night sky? So I'm pointing out a group of stars right up here where we got some really bright stars. This one is the closest star system to us. It says up there Rigel Kentaurus. This is Alpha Centauri. You might have heard of that one. It's very close to us, relatively, only 4.4 light years away. Then you've got Beta Centauri just to the right of that. Hadar, I don't ever call it that, I'll tell you that much. But the one I wanted to focus on is right here. You see Mimosa. Some of you might be thinking of your brunches that you've had in the past. Mimosa is part of a group of stars called Crux. This here is the Southern Cross. If you've ever looked at a flag of Australia or New Zealand, you will see 4 stars forming a cross shape. It's these 4 stars of Crux right here. And the reason why is because those 4 stars are extremely important in navigation to help find the South Celestial Pole, essentially where the pole star is not in the southern sky. So what you would do with this, I'll draw again. So here's one cross length right there. There's a second cross length. Here's a third cross length. Here's a fourth cross length. So 4 cross lengths away from the Southern Cross takes you to the point, I think I can't actually get this working again, but I'll try. Oh, come on. Yes, okay. This here, this grid pattern is showing you where the South Celestial Pole is, right where all those lines cross. Look at how close 4 cross lengths away is from the South Celestial Pole. So people would do that. They would use the Southern Cross to get them a sense of where due south is. Okay? So that's how you find the South Celestial Pole. There's no bright star down there, so they can't follow a southern version of Polaris, but they use the Southern Cross to find their direction of south. The binoculars that I usually use, there's lots of good reliable brands. I tended to, when I bought one recently, I went with the same folks who buy the best telescopes, to make the best telescopes. So the folks from Celestron or Meade or Orion, they all make pretty good binoculars. I think I have a 15 by 70 myself. So
The best binoculars for starting out are the ones that you already have.
that's a great point. That's a great point. Yep. Okay. Did everybody step out to go look at the ISS?
Can you name some of those binocular companies or whatever again?
Oh,
Just
sure. The telescope makers that I was talking about, I'm going to write it in here. Celestron, Meade, Orion are usually the top 3 brands that you hear about. And
Bushnell, if you can find older Bushnells that are not scratched up. Oh my goodness, that's my favorite flea market finds are the Bushnell telescopes. That was the same folks that were Bosch and Lohm for the glasses and the contacts.
Yeah.
Yeah, and it looks like we've got some information about buying telescopes also on our website on that resources page.
Okay.
So yeah, it's underneath the stuff where we've got our Cosmic Quest activities, our Zoom backgrounds, and our science activities.
Okay.
Yeah. Okay. Still love that my name is completely hidden by the green screen. I'll work on that. I'm gonna figure out how to get a better network so I don't get such a bad screen. Oh well. At least I can switch back over to screen share.
Thank you. Thank you for this. This is real fun.
Great. I'm glad you folks enjoyed it.
Mm-hmm.
It went a lot longer because you all had such great questions and observations.
All right, well, Erik, you should probably stop recording.
Oh, okay. I guess.